Okay, so let's get started. So we're saying we have this one, APs and GPs. Now, recently we agreed that you should let me know you agree with your friend Namakau what topic we are going to do, and let me know before 12 hours so that I can have enough time and prepare also. But she forgot to do that. She only informed me in the evening when I think I had even knocked off already. Or I was almost knocking off. What are you saying? Ah, but why do you mulata kuni kuko na doa? Hmm? Ah, okay, sorry for that. Yeah, so listen, you told me late, so nonetheless, we'll learn the APs and GPs as per requested. But the whole idea is I need to look for questions, like more questions that are on the topic so that we are well informed. Should any question come under APs and GPs, we should be sorted. There shouldn't be any question that should surprise you. Like I need to gather enough questions, make sure I explore all the tricks that are there under APs and GPs. And then I expose all those tricks to you guys so that should a question come under APs and GPs, no matter how the question will come, it shouldn't be a problem to you. You shouldn't fail. You shouldn't even be scared of attempting the question. So that's the whole idea of getting to know the topic in advance so that I organize those questions for you. Nonetheless, I managed to organize one question, but we can see how far we can go with it, and then if need be, then we can also do something tomorrow about the same so that I can organize more questions about the same topic. Yeah. So let's begin with APs. So this is simply we are saying when we talk of AP, we are talking of arithmetic progression. AP simply means arithmetic progression. So now in arithmetic progression, what you look for whenever you're given any sequence, you look for the common difference. Okay, common difference. Okay, so common difference which we call as D. So there should be a common difference that is under APs. So for APs we look for common difference. So let's look at an example. If you have a sequence of 1, 3, 5, 7, 9, 11, and so on and so forth. Okay, so there when you look at those numbers in that sequence, you see clearly that the difference between each two numbers is simply a 2. Between 1 and 3 there is a 2, between 2 and 5 there is a 2, between 5 and 7 there is a 2, and so on and so forth. So we have a common difference here. Okay, so that's what makes this sequence to be an arithmetic progression. Okay, why? Because we have a common difference. So this common difference in between is what makes this to be a common, to be an arithmetic progression. That's what you need to concentrate on. So now that we know that this is an arithmetic progression, there are just about two more things that you need to understand. Whether it's AP or GP, there are just about two things that you need to know. The first one is how to find the nth term. Okay, how to find the nth term. You need to understand how to find the nth term. Whether you're dealing with AP or whether you're dealing with GP, you need to understand how to find the nth term. Okay, so and the formula for the nth term here we're saying it's Tn is equal to a plus n minus 1 multiplied by D. Okay, so whereby this N is the term you are looking for, and then the A is the first term in this sequence. So A is the first term in this sequence. N is the term you are looking for. This N and that N are exactly the same. Then the D is the common difference. Okay, so in the question that we have here, in this example that we have, we know that A is equal to 1 because that's the first term, and then D, we know that D is equal to the common difference. So you can subtract two numbers starting with the, you can simply say Tn minus Tn minus 1. Okay, so if this is the third term, then from 3 you subtract 1, you get the second term. So what we are saying is 5 minus 3 will give you the common difference, or 7 minus 5 will give you the common difference, or 9 minus 7 will give you the common difference. So the common difference there is 2. Okay, so we can find, so we have 1, 2, 3, 4, 5, 6. We have 6 terms there. Patrick, which term should we find here using the formula to just prove that when we use the formula we get the exact term? So we have 6 terms there. Which term can we try to find using the formula? Term number what? Patrick? Patrick?
Yes, sir.
Come again? I'm saying which term there can we, which term here? Which term can we try to find using the formula to verify that the formula indeed is correct? I can't get you.
7.
What term is 7? Okay, Namakao, what term is 7? You can help Patrick. Namakao, what term is 7?
What term is 7?
Yes.
5. That's the 4th.
Okay, thank you, Patrick. Patrick is saying the 4th, Namakao is saying 5. Namakao, how is it 5? Patrick, kindly mute your mic if you're done. Namakao, how is that 5? Kindly explain.
Oh, I thought you said what term should we pair with 7? That's why I said 5.
But how do we, what do you mean by pairing, Namakao?
That's what I heard.
Okay. So, but you are okay that 7 is the 4th term?
Yes.
Okay, great. So let's find the 4th term. So I'm going to say T4, and we should get 7 because 7 is our 4th term. So T4 is equal to A is our first term, which is 1, plus N is this N here. So N is 4 minus 1. Then D is the common difference, which is 2. So this is equal to 1 plus 4 minus 1, that is 3. Okay, so this is 1 plus 3 times 2, that is 6. So 6 plus 1, that is 7. So we using the formula, we get exactly 7 as the 4th term. So that's how the formula works. That's how we use the formula to find the nth term. Any question on what we have done? Any question on what we have done? Now you should respond. Mwakambako che no question so that we move forward. Don't keep quiet. Come again.
I have a question.
You've seen now you have a question. I was even going to
I was
erase.
thinking on how how to ask.
Please,
So
please.
when you say the fifth term, which is number 9, we're going to find exactly the exact answer 9.
Yes.
Oh, okay.
The sixth term, if we put 6 here, meaning we're finding the sixth term. So here when we count 1, 2, 3, 4, 5, 6, which is 11, and if we put 6 here trying to find the sixth term, the answer will be exactly 11. There will be no difference.
Okay, that's all.
That's okay? Okay, so can we move forward? Okay. So the first thing you need to know how to work out is the nth term. That's what I said. So you need to know how to find the nth term. Either in AP or in GP, you must know how to find the nth term. Now the next thing you need to find is the sum to the nth term. Okay, sum to the nth term. So AP has got its own formula, GP has got its own formula. So for AP, we have the formula for finding the nth term, which I just showed you here, and also the formula for finding the sum to nth term is simply n over 2a plus n minus 1 d. So that is the formula for finding sum to the nth term. Okay, sum to the nth term. So now, you can decide to add, I don't know how many terms here. You can decide to add. So when you add those terms, then you can use the formula here, because sometimes you will not have all these terms here. You may only have the first one, maybe the fifth one, and so on and so forth. So you may not have all the numbers there, all the terms there. So it becomes tricky. That's why you need the formula in order for you to find the certain terms. Or sometimes you can be asked to find the 30th term. So you may not need to list down everything. You may need to use the formula and you should be able to find the 30th term or whatever term that you are asked. So now here, we want to use this formula to find the sum of S of nth term, any terms. So how many terms should we add here? We'll add them manually and then we'll expect to find the same answer after we have used the formula, just to show that the formula is indeed correct. So how many terms should we add here, Liseli? Liseli?
2 terms.
Oh, 1 and 3. So
Yes.
1 plus 3 we get 4. So we know 1 plus 3 is equal to 4. So we are finding the sum of 2 terms, which is going to be, so here the n is 2. So wherever there is n here, we're going to replace with 2. So here where there is n, we put 2 over 2. Then we have this, we have 2. Our a is 1, so we have a, which is 1, plus our n is 2. So I'm going to say 2 minus 1. Then our d is 2. So we have our d is 2, like that. So this is going to be 2 divided by 2, we get 1. So 2 times 1, we get 2, plus, here we are going to get 2 minus 1, we get 1. 1 times 2, we get 2. So we're going to have 2. 2 plus 2, we get 4, which is exactly what we have there. Okay, is that okay with everyone?
Yeah, we are okay.
Okay, any question? Any question? Okay, seems there are no questions. So, yes, Patrick?
I was saying like I don't understand.
Come again?
No question.
Okay, great. Wonderful. So we are done. Basically, with APs, we are done because you only need to know how to sum up and how to find a specific term in the expansion. That's all. For this, you are done. So we can quickly move to GPs. We can quickly move to GPs. Can quickly move to GPs. So with GPs, that's geometric progression. So with geometric progression, we have, instead of common difference here, we have common ratio. So here we're dealing with a common ratio, which we use as R. So we use R for the common ratio. So there we're dealing with the common ratio. Okay. So now a very good example I can give here is maybe we have 2, 4, 8, 16, 32, 64, and so on and so forth. Yeah. So there we have those terms in that sequence. Now, how to find R? We are saying R is simply equal to Tn over Tn minus 1. What do I mean? So if this n is 3, we are simply saying T3 over, here we are going to say 3 minus 1, which is 3 minus 1, we get 2. So meaning, if you have the third term here, which is 1, 2, 3, which is 8 over, down you should have the second term, which is 1, 2, which is 4. So 8 over 4, which gives us a 2. So that's what we have. That's how we find R. So it's Tn over Tn minus 1, or the term in front divided by the term the preceding term. So the succeeding term divided by the preceding term. So that's how we find our R. Okay. It should be very simple. I believe there shouldn't be anything difficult about it. So that's how we find our R. Now, also here we are saying you should always be able to know how to find the sum, not before we go to the sum, the nth term, okay? You should be able to find the nth term. Okay, you should be able to find the nth term when you're dealing with the GP. So I'm saying Tn is equal to A R n minus 1. So that is the formula that we use for finding the nth term. So we're saying nth term is equal to A, where we know A is the first term, R is the common ratio. Okay, so I'm dealing with ratios here. Then n is the term we are looking for, then we subtract it by 1. Okay, so I want let's pick a term here which we are going to find using the formula. Let's pick a term here which we are going to find using a formula. Yes, Namakau, pick any term that we can find using the formula there, just to confirm our formula.
The third one.
Come again?
The third term.
Okay, so what is the third term? Just to confirm whether what you are saying you understand. What is the third term here? Come again?
8.
Good. So we are looking for 8, which is our third term. So let's see, using the formula, if we are going to be able to get the third term. So I'm going to say T3 is equal to, our A is 2, so we have 2. Our R is 2, we have 2. Our N is 3, so I have 3 minus 1. Okay, this is equal to, so we have 2 here, we maintain the 2, then this is another 2 here, Then 3 minus 1, we get 2. So this becomes 2. Now 2 squared gives us 4. Then 2 times 4, we get 8. So we confirm that this is exactly correct. So we get our 8. So you can find any term here. Even the terms that are not here, you can find them using the formula. So that's how you use the formula to find the nth term. Any question? Any question on what we have done?
No question.
Thank you. So this is how you find the nth term.
I have a question.
Come again?
I have a question.
Yes, please go ahead.
Will A always be the first term?
Yes, A will always be the first term.
Oh, okay, thank you.
Sure, welcome. So let's move to the other part where we find the sum to nth term. Sum to nth term. So we're saying sum to nth term. Okay. So now there are two formulas here for finding the sum to the nth term. There are two formulas. Pay particular attention. There are two formulas. Number one, we have Sn is equal to A, then we have R to the power n minus 1 over R minus 1. This one we use it when R is greater than 1. Okay? That's when we use that formula. When R is greater than 1, we use this formula here. Then the second one is Sn is equal to A 1 minus R to the power n over 1 minus R when R is less than 1. So those are the two formulas that we use when finding sum to nth term for the geometric progression. You need to know this by heart. Okay? You need to have them because this is not like grade 12 where they give you the formulas. Here will not give you the formula, but you expect you to know what formula to use. So just to confirm whether we understand what we are doing. So Patrick, which formula are we going to use here to find, in case we want to find any sum here? The sum of, I don't know how many terms. Which formula are we going to use here, Patrick? Number one or number two?
Number 2.
Why?
Oh, you said we use the first formula R. So if 1 is less than R,
Come again?
you said we use the first formula our ratio is greater than 1.
Yes.
And then this second one, you said we'll use the second formula if our ratio is less than 1.
Yes. So now for this example, which one do we use? Do we use 1 or 2? In case we want to sum up some terms.
We use the first one.
We use the first one. Why?
Yes, because the common ratio is greater than 1.
Great. I hope everyone understand. So we are going to use this one. Why? Because our R is greater than 1. Because our R is 2. Okay? So because 2 is greater than 1, we are going to use this formula when if we are to sum up some terms here in this case. Okay. So listen, how many numbers are we how many terms are we going to sum up there? Quickly.
For fourth term.
No, there's nothing like that, Liseli. When you are summing to say nth term, it means you start from one, you are adding from one, you add until that term that you are looking for. So you add if the first 5, the first 10, the first 20. There's nothing like you skip the first one, then you come and add these two. No. So when we say sum to the nth term, meaning we start from the first one all the way up to that term which we are looking for. So how many terms are we summing up?
The first two.
But he said 9 with the first
I
two
don't
every
know.
time. Okay, so maybe let's sum up the first 4 because we know 16 plus 4 is 20, 8 plus 2 is 30 is 10. So this will give us 30. Okay, if we sum up these, we know we are going to get what? 30. I hope we are all okay. 8 plus 2, that's 10. 4 plus 16, that's 20. So 20 plus 10, that's 30. So let's sum up using the first formula here. So I'm saying sum, there are how many? 1, 2, 3, 4. Sum to the 4 terms is equal to, our A here is 2. So we're going to have 2. Then our R is 2. So we're going to have 2 to the power. Our N is what? 4. So 2 to the power 4 minus 1. Then over R minus 1. Our R is 2. So I have 2 minus 1. So this is going to be equal to, so I have 2. Okay, Namaka, what is 2 to the power 4? Yes, Namaka, what is 2 to the power 4?
32.
Are you guessing or you have solved?
Wait, I'm sorry.
You have solved it or you are solving?
I'm solving.
Okay, so we wait for your answer.
32.
Okay, Patrick, do you agree with that?
No, that's 16.
What is your answer if you don't agree?
That's 16.
Come again?
16. That's 16.
Okay, so for 2 to the power 4 is the same as 2 times 2 times 2 times 2. Okay, so this is to the power 1, power 1, power 1, power 1. When we add the powers, same base, that's what gives us 2 to the power 4. So we have 2 multiplying by itself 4 times. So we are saying 2 times 2, that's 8, that's 4. 4 times 2, that's 8. 8 times 2, that's 16. So here we get 16. So this will be 16 minus 1 over 2 minus 1 is 1. So we have 2. 16 minus 1, that's 15. Over 1, we get the same. So 2 times 15 is equal to 30. So we get our 30 exactly. So that's how you use the formula. Any question? Any concern? Any reaction? Any question? Any concern? Any reaction?
No question for me.
Okay, so we can move forward. Let's pick There's one question which was there in AME last year. It was also there in AEE. It was also there in avionics. The same question. So let's try to see how best we can handle it. Yeah, let's see how best we can handle it. So the question says, that was question 5. So we have AME 2023 November, December, question 5A. Okay, so if you have that paper, yeah, you can check it out. So it says 24 resistors, that's R1, R2, R3, R24 are connected in series. So the resistance of each resistor greater than the previous one by a fixed amount. If the total resistance of the first 4 resistors is 2.3 kilo ohms, and of the first 16 resistors is 14 kilo ohms. Determine the resistance of resistor 24. Resistor R24 in ohms. Okay, here it had 5 marks. Okay, so this is the question we have. That's the question we have. So we need to exercise our knowledge and see whether we have learned something or not. So I'm saying 24 resistors, R1, R2, R3, all the way up to 24, are connected in series. The resistance of each resistor greater than the previous one by a fixed amount. Okay, if the total resistance of the first 4 resistors is 2.3 kilo ohms, and of the first 16 resistors is 14 kilo ohms. Then determine the resistance of resistor R24, meaning the 24th resistance or resistor. So determine the resistance of resistor R24 in ohms. Okay, so let's ask ourselves a question. What is this, an AP or a GP? Quickly, anyone to respond? Is it an AP or GP, and give us a reason why? Yes. Is it an AP or a GP? Okay, there's a hand symbol down there, so you can press on it, then I'll be able to know that you have an answer. When you press on the hand symbol, you would have raised your hand. That's how we know to say, okay, you have raised your hand. Since this is a virtual class. Yes. Is this a GP or an AP? You can't be this quiet. I expect you to say something. Yes, Namakao, I've seen the hand.
I think it's a GP
Why do you say it's a GP?
because the difference between the progression is not an AP. I thought this would actually.
What do you mean it's not an AP?
Sorry, the first resistors have 2.3 kilo amps, and then the others go to 14 kilo amps. So the sequence in which they're progressing.
Aha, so Namakao, you missed the question. Let me read it again. It says 24 resistors, R1, these are the terms now. These are the resistors. So R1, R2, R3, all the way up to 24. These are the terms in the sequencing. Okay? And then we say these are connected in series. The resistance of each resistor greater than should be is. Let me confirm this question. Doesn't say sounds correct there. So yeah, there should be is somewhere here. So there should be is here. Is, so I say these resistors are 24. There's R1, R2, there are 24 of them. They are connected in series. The resistance of each resistor is greater than the previous one by a fixed amount. If the total resistance of the first four, now if the total, there's total here, total resistance of how many first four is 2.3 kilo ohms. So this is the total resistance of the first four resistors here. So pick the resistor 1, resistor 2, resistor 3, resistor 4. Now the total of the first four resistors will give us 2.3 ohms. And of the first 16, we get what? 14 kilo ohms. Then we're asked to determine the resistance of resistor 24 in ohms. Let's brainstorm again here. Is this an AP or a GP? And give your answer. I hope, Namakau, you are also making some considerations there. Yes, who has an answer? Quickly raise your hand and then I'll point at you. Yes, Diseli.
I'm just trying.
Yes.
Here the resistors are connected in series.
Yes.
And according to our knowledge, resistors connected in series, they add up. So me, I'm thinking it's AP.
Okay. You can withdraw your hand. Now, remember when I was teaching, I was explaining what really determines whether it's an AP or a GP. You have to remember that one. There are factors that will help us to know whether what we are dealing with is an AP or a GP. So I mentioned for you to know that this is an AP, they should be this. For you to know that this is a GP, they should be that. Let's try to use that and then as the reason to say, okay, based on this reason, this is an AP or a GP. Yeah, I hope you still remember those 2 points that I mentioned. Patrick, you are too quiet.
I think on that one.
Come again.
Why I'm quite good. I'm saying I think I missed that point, so I don't know.
Okay, you are far from your mic. You are far from your mic, Patrick. I can hardly get you.
What I'm saying is, I'm saying I missed on that point. I think that's the reason why I can.
Ah, okay, you joined a bit late. But were we not together when you joined? What happened? You had some network problems.
Yeah, I'm really having difficulty. It's kind of breaking.
Oh, okay, too bad. Namakau, you had raised your hand.
I think it has a fixed amount, and the progression between the resistors, the difference is 1 1 1 by each of them.
Come again, Namakau. I missed that one.
The difference of one between the progression between the terms is a difference of one.
How do you tell? Because we don't know what the first resistance is, we don't know what the second resistance is. How do you tell there's a difference of one?
Well, it is a fixed amount, so I assume it's one.
That assumption is not okay. Patrick, kindly mute your mic.
Okay.
So the assumption of one is not okay. Yes, it's not okay. Yeah, the assumption of one being the difference is not okay. But now there should be something that you should arrange from what you have said. You are coming up very well. You are coming up very well. So which one did you say? Did you say it's an AP or it's a GP?
An AP.
Okay, so I want us to figure out what this is because that's where the question is. The moment you are able to figure out whether it's an AP or a GP, then you can progress because everything just follows from there. So the main question is on identifying whether this is an AP or a GP. What makes an AP an AP? Let's begin it from there. What makes an AP an AP? Yes, Namakao?
The common difference.
Common difference. So whenever there is a common difference, then we know we're dealing with an AP. Now, what makes a GP a GP? Liseli, what makes a GP a GP? How do you know this is a GP?
Common ratio.
Common ratio. Now, from this question, what are you getting? Are you getting anything related to a common ratio or anything related to a common difference when you read out the question? What are you getting? Uh-huh. Where is it relating to? Something close, common difference or common ratio? Where are we? What's coming closer to your mind as you read through the question? Yes, Namakao.
Common difference. If it's a fixed amount, which means no matter what you do, if you subtract, you still get the same thing. So I think
Great,
it's
great, great. So you're saying the resistance of each resistor, all these resistors, each resistor is greater than the previous one by a fixed amount. The key word here is a fixed amount. Okay? So this one is greater by this one by a fixed amount. This one is greater than this one by a fixed amount. This one is greater than this one by a fixed amount. So there is a fixed amount between all the resistors. So this each resistor is greater by the other one only by a fixed amount. So if that fixed amount is 2, meaning the difference will be 2 throughout. If the fixed amount is 5, meaning that 5 will be the fixed amount and as the fixed difference throughout. So this word here, fixed amount, greater than the previous one by a fixed amount. This is what helps us to know that we are dealing with an AP. I hope we are all clear on that one. If you are not, please let me know before we can go ahead and solve the question. I hope we are all clear on that one.
But how do you know if it's a GP?
Great. So that's a good question. Yeah, so that's why I was complaining at first that I was given this topic quite late because I needed to organize questions also to do with GP. I've seen some questions. I think we solved some questions last time. I don't know if Liseli was there, but with the other team we solved some questions to do with the GP. Yeah, so I need to source for them again and then we need to solve them. We need to see to say, oh, this question when it comes like this is a GP. So I will need to look for those questions. That's possibly tomorrow. So I can't come up with something from my head at your level now. I can only do what I've done in the examples when I was teaching. But something technical like this, I may not bring it up from my head. I may need to sit down and think because everything should correlate. Hope that helps.
Yes, thank you.
Okay, so now let's move on to working out the problem. Now we are told that let's just write up some data here. The sum to fourth terms is equal to 2.3 kilo ohms, which is 2,300 ohms. Okay, then sum to 16 is 14 kilo. Now the kilo simply means 1,000. Yeah, when you hear kilo, it means 1,000. So we have sum to the first 16. Sum to the first 16 is 14,000 ohms. Okay, so this information is very important. Yeah, this information is very important. Very important. Okay, so now from there we say, now, since we know the formula, we are dealing with an AP, so we should know the formula for the sum of, for the summation of nth term. So the formula is sum to the nth term is equal to n, yeah, so I have n over 2a plus n minus 1 times d. That is the formula which we have. So now we're going to say sum to the fourth term. Sum to the fourth term is equal to, where there's n here, we're putting a 4. So 4 over 2, and then 2a. We don't know what our a is. We don't know what our common difference is. we don't know anything. So this is what we are trying to do. So we are saying plus n, which is 4 minus 1. Then the common difference we don't know is d. We don't know. So we don't know A, we don't know D, because for us to find the resistor R24, we are simply supposed to find the nth term. Okay, the nth term, the formula for the nth term is A plus n minus 1 times D. So that is the formula for the nth term. So since we know already the formula for the nth term, so what we need here is we need to have A, we need to have D, because here on n we have 24. We are finding the term for the 24th term. So you should have A, we should have here to be 24 minus 1 times D. So we don't have D, we don't have A for us to find the 24th term. So now, because we don't have D, we don't have those, then we are saying that becomes